Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on Groundwater Hydrology and Management. This is week 10, lecture 5. In this week, we have started to look at the groundwater resources data so that we can tie all the information that we collected in class into some product. It is good to understand the theory, but also we need to understand by data what is available so that we can make good estimations, recommendation plans, and preserve groundwater, which is very important. In the last lectures, we have looked at the aquifer type, the materials, the acreage, how much area it is spread, the key dominant materials, the types, the layering, all these things we have seen. Then we looked at groundwater table fluctuations to understand how much storage is there. In the last class, we looked at the groundwater resources. Basically, how much groundwater is available, the annual draft, and how much is taken out of this groundwater availability, the net availability. The draft is how much you take out from the net availability. The pumping data is used. So the last lecture we saw, we looked at groundwater level data. So the level data is used to estimate how much groundwater draft is taken. And out of the groundwater draft, bifurcations are done to see how much is given for agriculture, domestic use, industrial use, etc. All these are well captured in this data set. And all we have to do is carefully take the area that we're interested, be it India scale, the whole district, the block, any scale that we want. We have to take it carefully out and then look at it for in detail. Okay. So this is very important to understand how much groundwater we have and how much draft is taking place. So that is what we covered in the last class. It is also necessary to understand where the future groundwater is and how to extract that information. So that is what we'll be doing in today's lecture of the WRIS data portal. We'll be looking at groundwater prospects. Basically, where water can be taken and how much water can be taken. How is this estimated? This is estimated using the previous data that we discussed in the same lecture series. Basically, your aquifer type, the depth of the aquifer, the thickness of the aquifer, rainfall. I haven't looked at the rainfall data with you, but that is also in the same website. And also the storage, how much specific yield, storage, thickness, all these parameters are taken into account. The steps are carefully given in the website. So let's go through the website with you. Join me in clicking slowly through the website, and we will see how we could estimate these values. Let me share the screen. Okay, so we are at the WRIS website. Again, we go to WRIS data, we go to groundwater, we have finished exploration, we have finished the water level behavior and groundwater resource estimation. Now we will look at groundwater prospect study. It is a study taken from 2011. The remaining two we will discuss in the next week lecture series, which is artificial recharge structures and groundwater quality. So the web page has come up, and as I said, on your left, always you have your base map, layer list, print, etc. On your right, you have the menu or step by step how you should do. Even though it is given, I'm going to go through you and explain to you each and every step, so that if any doubt, we can directly click and understand if it works. So please join me. And the first things as it is choosing the base layer. If you want to change the background, you can change the background. This is the least computer internet intensive background. So you can just leave that background. And then you can look at the available data, the data panel, how to zoom into a particular location, all these stuff. Okay, so we come to the end. So now we have to select where you want the data. So the study has already been done. Okay, to know about the study, you can go and look at the user guide, how the study was done, what kind of surveys, what kind of methods they used. Right now, I'm not going to go into that part because that itself is a full lecture. What we'll be looking at is, based on the study, where is the groundwater location? So let's take a state. As usual, let's take Maharashtra. It is not sometimes arranged in a particular order. So sometimes you'll see not in alphabetical order, but let's see if they have Maharashtra. They don't. So let's do Tamil Nadu. And just wait for it, it will populate. So now you have it gridded. You see the entire state is being cut in a big grid. So grid is something like your graph sheet. You have a grid, and within the grid, there are smaller boxes. So each box is a tile, and you can actually take the data out. So if you see, when I zoom in, there are towns. The dot means towns, where the towns are, and is there the data available? RGDWM sheet, which is the groundwater resource development data. Is it there? If it is yes, it is in a particular light pink color. If it is no, it is a dark pink color. So there is some data here, there's no data there, etc. Okay. So let's select a district. Let's say Chennai. I'll do Coimbatore because it is on the dry belt. Yeah. So you see, you have some areas where you have groundwater, the resource, and then you can say get grids. So now it will populate where the grids are available with the groundwater data. For example, these are the grid names. Each grid has its own name. Right now, you cannot see what is the grid name. You can only see the major grid, which is 58E. Okay. So 58E is this grid, and then 58A is this grid. Within the grid, you have B15, etc. Okay, so let's select in this region what we have. So this is the major grid, the green one, and then you have the subgrids. Okay, and as I said, it tells you if the data is available or not. So I'm going to click first one just to see if there is a data, and it goes zooms in. That is Coimbatore, one part Valparai, and you have towns. Is it unnamed? Some legend is unnamed. Do you have the data? I think is yes, green. No is not green. So I think it has the data. So you can download the data. Okay. So when you go in and download, you will find more of what that data has as a map. Okay, let me show you. Download as PDF. And then again, I get academics. I get my name. It will download as a PDF like a report. Okay, and in that report, you'll be able to find out how this groundwater is stored. Okay, I'm going to put it on my desktop and then take it out. I've clicked it. It will just open in a minute. So it takes some time. So don't worry about, that's why I'm just walking through with you on doing this data set. It is a big file. So sometimes don't just download everything. Just see how it is. Okay. So here it is, that district what we saw, and each color is given. Okay. So they've given different colors to show you like a map what it is. And because you are in PDF, you are able to zoom in. It's a very detailed map on groundwater prospects prepared from satellite image interpretation with limited field checks. So they're very particular. Don't claim that no, this is the best map. They say that yes, we've done it, but with limited field checks. Okay. So what does it tell you? The map units are green, red, green, and inside the green, if you see, it is either a line going like this or a straight line. So all these different aspects are given for you to understand that each coloring is different. Instead of using 10, 15 colors, they'll use straight lines or dashed lines or dots like that. Then you have the geology sequence. What is the geology in that particular area? It is granite. So in the previous one, we saw it is aquifer material or aquifer type. So that is given here. What type of land formation it is? It is a valley. A valley is like this, right? So as I said, the Western Ghats is on the Kerala side, and then you come down to Coimbatore. Coimbatore, some part of Coimbatore is on the hillside, but most part is still not there. So that is the valley. This is called the valley. U-shaped place is called the valley. And then the depth to water levels, it says no wells are there. Data is not entered. Recharge conditions, is it good, moderate, based on their metrics. Okay. Aquifer material is what type of material? Is it WR, which is weathered rock? Weathered rock will have more water. Or is it loose material? And then you have the type of wells. What type of wells are found in this location? We have BW, and BW it is given here as bore well. So you can see that even though it is in a hilly region where there's a lot of rainfall and some rain shadow region, people don't use shallow wells. They go for deep wells because it is for them it is easier to put a deep well and then extract all the water. So you'll see all these bore wells included, not much deep come bore well. I've seen in this area physically in the field visits, there are a lot of dug wells. Okay. But as the data suggests, it is not fully field checked. Okay. So don't worry about where it is and how it is. Here we are right on the border of this is Coimbatore. So some data is not there, which is fine. And then we have the depth range of wells, how deep it is, 40 to 60 meters. So it is a deep well, and the deep well goes 40 to 60 meters. That's what they're saying. And then the yield range of the wells is given 100 to 150 liters per minute or meter cube per day. So if it is a big well and it is giving a lot of water, people run it for a long time and then they put it as meter cube per day. Whereas most of the time it is liters per minute, how much it is pumping. So they'll run it for 1 hour or 2 hours. And then they'll note down the pumping volume in the wells. Then quality of water, is it good? Potable. Potable means can you drink the water? Can you use it for domestic use or not potable? Okay. Indicate reasons why not potable. Non, N-O-N, potable. So everything is given here of whatever they use. Sorry, I missed this one, which is homogeneity of the unit access. Is it across the area pura? Is it the same material, the material that you find here? Yes means homogeneous. Moderate means some places it is homogeneous. Low means it is not homogeneous. So you can see that most of the places are moderate and high, which means good homogeneity across. The quality of water is there as potable. And then you have groundwater irrigated area is negligible because they have good rainfall. Maybe they're not doing groundwater irrigation. But then why is the pump so deep? Okay, why they're using deep wells? They could use dug wells, right? So that data is not carefully put. or also the irrigation is not needed because most of this time it is raining. So that rainfall is enough to recharge the soil and grow the crops. Recharge structures, is it needed? Percolation tanks, if so, what type of recharge structure? So now they're giving recommendations. What type of recharge structures can we give? Is it not required because the water levels are good? Or do you want percolation dams, check dams, nala bunds, recharge wells, desilting tank, or recharge pits? All these are given. See, each recharge structure goes with the recharge need and the type of the soil or the material. You need to have rainfall. I've explained this in class. And you also need to have lot of structure in the rock and the soil material to hold the water. And this is where you need to balance both these aspects to find a particular recharge structure type. They have done this for you, the groundwater board, and given you the details of what can be used. Good. Then also we can look at what is the remarks. Forest area, no habitations, forest area, forest area. So it is the remarks given by problems, limitations, and or the field survey person who did it. They might have found some issues. For example, the groundwater wells were not able to be checked. Sometimes I've seen locks put on these wells. People do not want us to monitor it. And if it is only the groundwater board data, then it's fine. Everyone can monitor it. Sometimes access is denied. It is around it. They put a lot of structures, so you would miss the groundwater well. And sometimes your well is tampered, which means the instrument inside is taken out, or some stones are put on the well that you cannot see it. These type of things sometimes happen not knowingly, because right there is some agriculture, or they're building a house. They didn't know there was a groundwater monitoring tube there. They just put all the rubble. So all these problems can be put in this area. Mainly runoff zone, borewells have to be located in identified location zone for expected yield. So all these prospects are given in this map. So this map mostly has captured the Kerala side of the Western Ghats, not the Coimbatore side. But again, it is useful because it has given you good data about what is available. And this is not a GIS layer, it is a GIS converted to a PDF. So which means you don't need a software, you just need a PDF viewer. Take it and put it in your report, you can cite it. So let's take one more example in Punjab, for example. You have to clear grids, clear the district, and then go to the state. Let's say Punjab is there. Yes, Punjab is there. So now the computer the software has taken us to Punjab. It says only some is available. If you look at the coloring, yes and no, the no color is more. So I would go to Himachal, just because we don't have the data. Even Himachal, not much covered. So let's go to Bihar. Yeah. Okay. So I think the color is different in different screens. So just I would say download the data and then see if it works or not in your system, if the data is available or not. So I think Himachal Pradesh will stick, because this area we do have. 53E is good, Shimla is good. So let's take Shimla. If I went fast, I'm doing it again. Okay, I go to select grid code for the state. So I selected Himachal. Then I come here, it has populated all the districts in Himachal. I go to Shimla. Why did I go to Shimla? Because somewhere here I see a bright color, meaning there could be data. So let's put Shimla and then get grids. Get grids. Good. Now we'll close. We can select a grid here, or you can select it here. Okay. So let's select 5314. Let's do the 50K. 50K means the resolution is different. Okay. So I'm going to do 5310. It's coming in this side. Yes, data is available. Okay. If I click this 5310, another box can open asking me to download the data. Okay, I'm going to store it again. Opening the data. Yeah. So this is a very good representation, and all the prospects are given. So if you look at it, you have the stream networks also mapped where the river flows, and along the rivers there's lineaments. The blue lines are where cracks are there. Remember, Himachal has a lot of hilly region, so it has a lot of these cracks in the water that can cracks in the rock that can store water. Okay, so this map is pretty good, and you can see other maps that can be used with it, the coloring, where in India it is. So all of this has been done for you. All you have to do is cite it properly. Do not just copy these maps into your work and say it is your work. The government has done it for you, so always cite. Here you have the copyright information, who to cite, all these things. Okay. So this is a great exercise for you to use this groundwater resource map, and then understand the potential, the regions where the recharge can happen. For example, let's take this region, the light blue versus the red. If I come back this side, you can understand that the light pink has, see the numbers, zoom in more. Yeah. So the light pink and the red. Okay. So the light pink has poor water recharge conditions. So there's nothing that you can do. And that is why you see all these cracks in the surface. And right next to the pink color, the dark reds we saw are a little bit better. Okay. So you can see the recharge, the links, everything. Because of the material type, you could say that it is a little bit better, but still, because it is on that region along the hills, it is not good. But if you come down, sorry, come down or up, only some regions in the yellow color are having moderate to good recharge conditions. And if the recharge is high, you have tube wells rather than bore wells. Tube wells are also going into the deep aquifer, but not too deep. Okay, it's limited, and so energy consumption is less, water usage is good. Okay. Then you have the flow rate, which is 80 to 100 meters. I'm sorry, this is your depth of the well, which is 80 to 100 meters. And then when you go to the red zone, the depth increases. The yield is very high, 50 to 100 liters per minute, whereas in the red, it is only less than 10 liters per minute. And then the recharge conditions, homogeneity, etc., etc. The good thing is the water quality has always been good. Potable, potable, potable. For example, in Nepal conditions in the same hilly regions, you would see polluted water mix into the groundwater, and it is not potable. So you have to be careful in understanding the differences between potable, which can be used for drinking, and non-potable. And not many recharge structures can be put on the hilly regions. That is why they put the dash dash, which means nothing. Or you can do some DG, dug wells, or ST. ST is your small scale dug wells, low priority, not high priority. They say it's very low. Okay. I would recommend you to read through the user books to understand more on these terms and how they estimate these values. Okay. So now I'm going to go back to my presentation. Okay. So what steps did we do? We have identified the groundwater prospect map. We have learned how to read it, and you can download the data as and needed. Okay. So this is the grid file. This came from each grid file after the district, after the state that you take. So I would do the artificial recharge in the next week in groundwater lecture series 11. I'll also teach you about the other groundwater reports that you can access for quick learning. And one more thing is satellite data. I will look into how you can estimate groundwater using satellite. It's a very cool tool. I will show you the live satellite, how it looks at the Earth, and how you could take the data out and use it. You would need GIS, but again, we are not getting into that part. So I'll just give an introduction. So with the recap of the week 10, we have looked at aquifer 2D mapping, where we discuss about the type, the material, and the depth to the groundwater. We looked at the groundwater data from both the state and the Central Groundwater Board. We have understood that not all wells, even though you have 33,000 wells, not all are used for monitoring. Only 15,000 wells are used. And of the 15,000, there are some which monitor the deep aquifer, and whereas some monitor only the shallow aquifer, or many. Then we looked at the data trends. We understood that for India, it is almost in the safe condition because 60% critical issues are happening, or 60% of the water is only used. So semi-critical level we are. But if you zoom into districts and zoom into certain blocks, you will find that the groundwater data is extracted more than the recharge, which is not sustainable. Then we looked at the groundwater resources assessment, where each block has a groundwater assessment of how much groundwater is recharged, how much water is taken, and out of the how much water is taken, what is the percentage used for irrigation, what is the percentage used for domestic and industry. They're clubbed together, but again, there are some breakups of these data that you can find. The groundwater artificial recharge is a very necessary aspect for which you need to understand the geology, the groundwater setting, and that is what we looked at in today's lecture by going through these maps, the groundwater prospects maps. Now, if you have a high prospect, that is where you're going to go and put your groundwater recharge. So the link is, we have set up all the data. Now we have understood where the groundwater potential is high. The next lecture, we will look at where the groundwater recharge structures have been placed and what are the benefits. With this, I would conclude today's lecture. Thank you.